Welcome all of you. This is my first video for organic chemistry. Okay, uh, organ- organic chemistry for students who are preparing for JEE and NEET. Okay, so whatever I am going to teach you, it will be for solving questions. So not for the CBSE student who just want to get good marks in CBSE. This is especially competition oriented. Okay. My background is chemical engineering, so I'm not a chemistry teacher. I learned chemistry or mastered chemistry during my preparation for JEE long back. Okay, so I taught few friends, then I taught few students for this. So I can and assure that you that okay, if you follow me, you will be able to solve maximum problem in NEET and JEE. Okay, so here are some tips. Since a lot of memory is involved in chemistry in organic chemistry, what I need from you, I need from you to revise whatever like for today lecture, re- revisit again within 2 3 days before it goes away from your memory. Okay, this is very important. Then then you have to revise again after 1 week the same syllabus, same thing which you learned or you watched the video last week. Revise again. Okay, make your notes whatever. Then slowly it will go to your memory for long time. Okay, long term memory. So as material builds up, so as we continue, you will have a lot of reactions and so on. So always start from beginning. Revise and revise. Now students, they don't want to revise. Why? Because there's temptation to move ahead. No, consider all organic chemistry as one chapter. Okay, there is no ether and alcohol and this. No, don't think like that. Organic chemistry is one chapter. Okay, this is important. Organic chemistry is one chapter. Is one chapter. All are connected. You cannot separate them. You can say, okay, I know aldehyde, but I don't know alcohol. No, there's nothing like that. Okay, and then we have a big debate uh, about like organic chemistry can be mastered just by memorizing the equation, or you need to understand. Okay, understand the concept, the mechanism, and so on. Okay, so these are two extreme views. Neither this is 100% correct, nor this is 100% correct. Only memory, just memorizing the reaction. No, you can't. Or only understanding without any help of memory. No, you need memory. So you need to understand the mechanism. We'll do the mechanism. Okay, concept. We build the concept, but at the same time, you need like not like mugging, but you need a systematic revision to keep the things in your memory. Okay, so there is balance between understanding and memory. Okay, so now let me start without any delay. I will start the first chapter as basic organic chemistry. Okay, this one there could be other names like reaction mechanism and so on. Okay, so this is basic concept, means the fundamentals involved in organic chemistry, which will be used to explain the things. Okay, so first thing is inductive effect. Okay, again, I'm not going to give you the definition and to write, but just I will explain and what is the application of inductive effect, how we use this. That will be my focus. Okay, so inductive effect, let me explain to you with an example. uh, Covalent bonding, right? Cl molecule, Cl2, right? So what we have here, sharing of electron. So two electrons are here shared. Okay, two electrons. Cl and Cl, two molecules, the two atoms, they are same. So electronegativity is the same. These electrons are exactly in the center. Why? Because both electronegativity is the same. It's not either here, not here. It is exactly in the center of the bond. Okay, that's Cl2. What happens when I replace this Cl with H, and then we have HCl molecule? Okay, now chlorine and hydrogen both has different electronegativity. Electronegativity, what is electronegativity? Negativity? Electronegativity is power to attract the bonded electron. Okay, so what happens here? Bonded electrons is partially shifted towards more electronegative atom. That's the Cl here, chlorine. So what do you have here? Now electron is here shifted a little bit towards Cl. So electron is negatively charged, so it will have partial negative charge, and this will have partial positive charge. Delta is partial, right? So that is called inductive effect. Permanent transfer of, okay, permanent shifting of bonded electron towards more electronegative atom in a covalent bonding is called inductive effect. Okay, make sense? Now let's see how we use this. How we use this? We'll come to application right away. Okay, for example, one of the application here to explain the acidity trend of carboxylic acid. Carboxylic acid. So carboxylic acid is basically weak acid, right? Why? This is organic acid. How to define that? Like for example, HCl is inorganic acid, it's a strong acid, right? It will break into H plus Cl minus. Complete dissociation of bond H plus Cl minus. Now carboxylic acid is weak acid. This is organic acid. So it also has H which it can remove. Okay, which it can give H plus ion. So H plus ion. So H plus the ion is called carboxylate ion. This is, we can say CH3, or we can make it general alkyl group. This is called carboxylate ion, and this is H plus. So this is acid. Now we compare the acidity. What happens when I replace this one of the hydrogen of this alkyl group with the something more electronegative group? For example, Cl, CH2, COOH. Now this becomes a stronger acid or weaker acid. So how we approach, how we decide? We decide based on, is it become easier for it to give H plus ion or difficult because of this Cl. Okay, now Cl, as it has high electronegativity, it will attract the bonded electron towards it, right? So we are applying inductive effect. So this is shifted towards Cl, then this was shifted towards in this direction, and so on and so on. Now the bonded electron is shifted more towards oxygen. So H will feel little free. So H will, hydrogen atom will leave the bonded electron, this two electron, and give H plus easily. easier than the easier than this one. Okay, and then this is carboxylate ion. So it means that introducing Cl make it more acid, more acidic. Okay, makes sense. We are applying inductive effect. So acidity trend Cl CH2 COOH is acidic, more acidic than. Okay, now Cl and F. So suppose we have F fluorine. Which one is more acidic? Fluorine is more electronegative, so the power it will attract the electron more than Cl, right? So same effect, but this effect will be in this more, in this case more. So this is more acidic than this. See, these questions are coming in exam, in test, right away. So if you want to write a train, so then F CH2 COH is more acidic than Cl COH. Then if you say Br bromine based on their electronegativity. Okay, this is one of the application. Now, how to explain this for, like, in carboxylic acid itself? Suppose formic acid HCOH and CH3COH. Okay, so this is before this we need to explain one thing. Methyl group. Okay, so we have in inductive effect we have plus I effect and we have minus I effect. Okay, this one has minus I effect because it attracts the electron. Okay, so minus I effect, minus I effect. Okay, minus inductive effect. All Cl, Br, F, oxygen group, OH, all will have minus I effect. It attracts electron, right? It attracts bonded electron. Now, what if releases the electron? There are some group which attracts the bonded electron less than hydrogen. Hydrogen uh, is considered as neutral. Okay, so some group which uh, which releases electron opposite. So that's the methyl or ethyl or alkyl group, all alkyl group. So when we say CH3 CH2, okay, Cl, if we consider this one, this is electron releasing group, electron releasing group. So it will give electron to away from itself. So this is electron releasing group. Okay, so bigger the alkyl group, more it will be the effect. So minus I effect plus I effect. So this is electron releasing group. Now let's see formic acid. So now if we have formic acid and we have acetic acid, which one is more acidic? Remember electron releasing group. Okay, now this is electron releasing group. So movement of electron slightly shifted from methyl, electron releasing group, from methyl to carbon. So this will be in this. In that case, now electron is shifted towards hydrogen. it is difficult for hydrogen to leave H plus, because it will leave the bonded electron here, two electron here. So this becomes difficult to leave. So this becomes now weak acid, not easy. Which gives H plus easier is the stronger acid. And this effect is not here. This only hydrogen. Okay. So if you compare this plus I effect is more here. So if you see formic acid, acetic acid, propanonic acid, formic acid is the strongest acid. Okay. So formic acid is the strongest acid. As I said, we increase the length of the chain. So this effect is more, plus I effect. Okay, OH and so on. Okay. So this is the inductive effect, application of inductive effect. One application we saw. Okay. Uh, Quickly I can explain to you stability of carbocation. Okay, just in 2 minutes, and we will do more discussion on this stability of carbocation. If you know carbocation, in which there is positive uh, charge, positive charge on carbon, positive charge on carbon. This is called carbocation. This is intermediate. Okay, when we do reaction mechanism, we'll find, okay, sometimes intermediate is carbocation, carbon positive. Okay, so when we have like tertiary carbocation and then secondary carbocation, what do you mean by secondary carbocation? Secondary carbocation means, please listen, okay, positive charge on that carbon, positive charge on that carbon which is connected to two carbon, positive charge on that carbon which is connected to two carbon. So that's secondary carbocation. So you must have heard about this secondary carbocation, tertiary carbocation, and this is tertiary carbocation. This is three carbon. Now methyl, methyl, methyl. Suppose then all has electron releasing group. So it will give electron to this, and this in this case from two side. Now when we compare the stability of two charged species, you know, suppose one is neutral, one is charged. Which one is more stable? Neutral, right? Because charge will have extra energy, more energy, less stability. Okay, so neutral is more stable than charge. Now, two charge. This is also having charge, this is also having charge. How to compare the stability? Somehow, if we can see that one has having less charge than other, and one has some effect because of that the charge is neutralized somehow. Okay, now see, methyl group, methyl group will give electron releasing group, right? So it will give electron to this, same methyl here, tertiary to this, and if it is methyl also, this is give. So electron coming to this carbon, electron is negatively charged. So what it will do, it will neutralize, it will reduce the charge on this. Okay, charge is being neutralized, so charge is getting less here. Same effect is there also, but less than this. This is from three side, this is from two side. So stability of tertiary is more. Why? Because charge is getting less here because of the positive inductive effect, electron releasing group, electron releasing group of this methyl, 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 three side, two side. So which one has less charge? This one has less charge. So a stability trend, tertiary greater than secondary, greater than primary. Okay, we'll discuss more and we'll continue on this. Already is 20-minute video, so I will stop now. Okay, so see you for next video. Thanks.